Hello friends, Standard 11 Chemistry Unit 2 Structure of Atom Part 1. First of all, let's start. What is atom? Smallest unit of element. Smallest unit of element. It is called atom. This word is derived from the Greek word atomio. It's a Greek word. That means uncuttable or undivisible. First of all, in atomic structure, atom in the nucleus having positive charge, proton, and neutral particle, that is neutron. It is said to be as nucleus. This nucleus is surrounded by electron having negative charge. So fundamental particles of the atoms are positively charged proton, negatively charged electron, and no charge particle, that is neutron. Now let's see the basic information about proton, neutron, and electron. Here the symbol for proton, then after electron, and neutron. For proton P plus, electron negative, and neutron having no charge. And its absolute charge, absolute charge in coulomb plus 1.6022 into 10 raised to minus 19 coulomb, while in for electron negative charge 1.6022 into 10 raised to minus 19 coulomb, neutron having no charge, zero charge. Its mass in kg, kilogram. For proton 1.67262 into 10 raised to minus 27 kilogram. For electron 9.10939 into 10 raised to minus 31 kg, and for neutron 1.67493 into 10 raised to minus 27 kg, and its mass per unit, that is equal to 1.00727 for neutron. For electron 0.00054, and for neutron 1.00867, and its approx mass per unit, that is equal to 1, 0, and 1. So this is the basic fundamental idea. And last, its relative charge. Proton having positive charge, electron having negative charge, neutron having no charge. This is a negative, so no charge. Okay. Proton experimentally discovered by Goldsmith. Electron discovered by J.J. Thomson, and neutron discovered by Chadwick. Now let's see the atomic number. It is denoted by capital Z. What is atomic number? That means number of proton present in nucleus of neutral atom. That means we can easily write Z equal to number of proton, and that is also equal to number of electron. Z equal to number of electron in neutral atom. This is very most important word, neutral atom, for a number of electrons only. Okay, so the number of protons never be changed. That means atomic number, every element has specific atomic number. For example, here for hydrogen, its symbol is 1, H, and its atomic number is 1. Okay, hydrogen, then after helium 2, lithium Li, its atomic number is 4. Hydrogen, helium, lithium, then after beryllium B, boron capital B 5. So at least we should know 1 to 30 elements and their symbols and atomic number and atomic mass also. So let's see what is atomic mass. Atomic mass, it is denoted by capital A. That means here total number of proton and number of neutron present in the nucleus of neutral atom. That means in short we can write here A plus A is equal to proton plus neutron. It is collectively known as nucleons. It is collectively known as nucleons. From this data we can write here total number of proton that is equal to Z. So we can write easily here Z plus neutron. Now let's see the symbolic representation. Symbolic representation of atom. X, that is symbol of element. Z, it is atomic number, and A, it is atomic mass. Okay, suppose we have element, that is sodium, and its symbol, that is Na. It is said to be natrum. Okay, for said sodium, it's Latin word natrum, and from this Latin word its symbol is Na. Okay, its atomic number, that is equal to 11, and atomic mass, that is equal to 23. Now from this data, this is the neutral atom, it is said to be neutral atom. Okay, and it is said to be ion, sodium ion. This is the basic difference, is neutral atom and it is sodium ion. How it becomes from neutral atom to sodium ion? This neutral atom that loses of one electron, this sodium atom loses of one electron, and it is converted to sodium ion, that means positive ion. Positive ion. Okay, so this is the basic fundamental idea. Suppose here sodium loses of one electron, then so let's see here M, that is neutral atom that loses of one electron, it is converted to M plus. Suppose it loses 2 electron, it is converted to M2. It is loses to 3 electrons, M3 plus. This is called cation. How can you easily identify T, cation, that T, T represents the positive charge, so it is said to be cation. Okay, suppose here this neutral atom M, neutral atom gains of one electron, its gain of electron, it is converted to negative ion and it is said to be as anion. Okay, here the losses of electron, here gains of electron. Suppose M, neutral atom, it gains 2 electron, M2 minus. Suppose it gains 3 electrons, M3 minus. Okay, now calculate number of proton, neutron and electron in sodium 1123. Okay, let's say here sodium, it's a neutral atom, they're having no charge, either positive or negative, no charge, so it is said to be as neutral atom. This represents 11, that represents Z, 23 atomic mass A. From Z atomic number Z equal to 11, that means number of proton never be changed, 11. Then atomic mass capital A equal to 23. One thing is, remember that in neutral atom always number of protons that is equal to number of electron. For only neutral atoms always number of protons equal to number of electrons, only for neutral atoms. Okay, now atomic mass is equal to 23. As we know that number of neutron that is equal to, in short, directly we can write here A minus Z. A that is atomic mass, Z that is atomic number, it's 11, so it is said to be 12. In short, number of neutron that is equal to atomic mass minus atomic number. Neutron equal to atomic mass minus atomic number. It's very simple, short and sweet. So total number of electrons and protons are 11 and neutrons are 12. Let's see here. Deuterium nucleus contains, options are 1 proton 1 neutron, 2 proton 0 neutron, 1 proton 1 electron, 2 proton 2 neutron. Deuterium, these are the isotopes of hydrogen. There are 3 isotopes of hydrogen. Protium, deuterium and deuterium. Its atomic numbers are same. Its atomic number are same, but atomic mass is different. So it is said to be as isotopes. For deuterium, this is the symbol of deuterium, D21. That means here its atomic number is 1 and its atomic mass is denoted by capital A. Here it's a simple atomic number Z, means here 1 proton 1 proton. From this data we can easily write either these options or these options. Here for neutron, one thing is keep in mind, in neutral atom always number of protons and number of electrons are said to be always same, but here in this case 1 proton plus 1 electron, so these options are is not correct, this is incorrect. Okay, now it's not applicable because our atomic number Z that is equal to proton is 1, so these two options are not applicable, so only one from these option. And now what about 1 neutron? We can easily calculate it, number of neutron that is equal to A minus Z. A that is equal to 2, Z equal to 1, that is equal to 1, so number of neutron that is equal to 1 and number of proton that is equal to 1, so this is our answer. Now let's see another atom of element that contains 29 electron and 35 neutron. Deduce the number of proton and identify the element. Options are Cu2 plus, B Cu, option C cobalt Co, option D Ni nickel. We have 29 electron and 35 neutron. For the atom of here, total number of proton, that is question mark. So number of neutron equal to 29, neutron equal to 35. Then what about proton? Because from these proton we can identify Z that represents the particular element, because it is atomic number, it is directly connected to atomic number. Okay, but here is the neutral atom, so that means here atom that here, suppose it is said to be ion, either positive or negative, it doesn't matter, but we have atom, that means it is considered to be as neutral atom. And always one thing is remember, total number of electron in neutral atom, that is equal to always total number of proton. That means here total number of proton equal to also 29. Now this 29 that represents the atomic number is 29. So our atomic number is 29, that represents the copper element Cu. Okay, now we have another data 35, because identify the elements, that means we have X, Z and A. From this data we can easily write Cu 29. But what about atomic mass? Okay, so we need here atomic mass, neutron equal to A minus Z, A question mark, but Z 29, neutron that is equal to 35, A equal to 35 plus 29, 4 and 64, A equal to 64. That means our identify the elements, this is our answer 64. Copper 29 its atomic number, 64 atomic mass, and X that is copper. So now we can easily write here, this will be our final answer. Try yourself. Atom of element contain 30 electrons and atomic mass is 65. Deduce the number of neutrons and identify the element. Options are Zn zinc, Zn2 plus zinc ion, nickel Ni, and nickel ion Ni2 plus. Now let's see another example. Give a number of electron in species H2 plus, H2 and O2 plus. Here let's see for H2 plus. In this case we have two atoms of hydrogen and it is said to be positive charge. When it becomes positive, that means it loses of electron, number of electron loses. Here only one charge, one positive charge, that means here it loses of one electron. Okay, so we need to minus 1 here. For atomic number of hydrogen, atomic number of hydrogen is 1. That means here number of protons equal to 1, but we need to calculate the number of electrons here. That means here in neutral atom electrons are, number of electrons are 1. Okay, so from this calculation number of electrons are 1 plus 1 minus 1 because of the positive charge. 2 minus 1, that is equal to 1, means here number of electron in H2 plus ion, that is equal to 1. Let's see here hydrogen. This is the molecule which is made up of two hydrogen atom. So here its atomic number is 1. That means number of proton equal to 1, that is equal to number of electron because it's a neutral. This is the neutral atom, and from this data we can write here 1 plus 1 equal to 2. Number of electrons are 2. Now let's see another data. Oxygen O2 plus, O2 plus, that means here it loses of 1 electron. Here we have two oxygen atom and its atomic number, that is 8, and minus 1 electron. That means here number of protons are 8, that is equal to number of electrons are also 8 in neutral atom. So 8 plus 8 minus 1, 8 plus 8 16, 16 minus 1 15. So number of electrons are 15. And this is the exercise of 2.27. Now let's see here how many electrons are present in cyanide ion. Cn minus, number of electrons, how many numbers of electrons are present in cyanide and Cn minus. In this ion we have two atoms, number 1 carbon and number 2 nitrogen. Here negative charge, negatively charged, that means here it gains of 1 electron, it gains of 1 electron, that means equal plus 1. Okay, is the charge, that means gain of 1 electron. Here for carbon its atomic number is 6, for nitrogen its atomic number is 7. One thing is keep in mind, it's a neutral atom, it's a neutral atom, that's why its number of proton equal to 6 equal to number of electron. So number of electron equal to 6 for nitrogen. For nitrogen, this is the, for carbon, is for nitrogen number of protons, that is equal to 7, that is equal to electron. So number of electrons are 7 and it gains of 1 electron because this is the negative charge, that means plus 1. 6 plus 7 13, 13 plus 1 14. So in this ion, in this ion cyanide ion, number of electron present are 14. Here suppose it's Mg2 plus, Mg2 plus, number of electrons, how many number of electrons present in Mg2 plus and magnesium ion. Now for magnesium ion, its atomic number is 12. 2 plus, that means it loses of 2 electron. From this data we can easily write plus protons are 12, here electron 12 minus 2, that means number of electrons are 10. Okay, try yourself. Number of electron present in sodium ion, potassium ion, calcium ion, sulfide ion, nitrogen ion, N3 minus. Okay friends, next time we will discuss another topic and another example. Thank you very much.